If you want to have the copy of the module, I've linked it in the description of this video. Closure property. When we say you're going to add two integers, is it still going to be an integer? That is the question that the closure property asks. So if we try 3 plus 5 equals 8, then yeah, since 3 is an integer, 5 is an integer, the sum of them is 8, is also an integer. The same way applies to 3 minus 5, which is negative 2. Integer, integer, subtract that, will also give you an integer. So we can say that adding two integers has a closure property, meaning that the result will also be an integer. An example of not having a closure property is odd numbers. 3 is an odd number, 5 is an odd number. If I add those two, will it give me an odd number? No. 8 is an even number. So we can say adding two odds does not have a closure property. We have here the identity for addition and multiplication. For addition, to find the identity property is simply get any number you're going to add. Since we're in addition, it's inverse. A number, adding its inverse will result in the identity, which is 0. Because the identity property of addition is when you add 0 to any number, in this case 325, it will also give you that number. For multiplication, to find the identity, you get any number, multiply its multiplicative inverse, and you would get 1. This is why it's called the 1 property, and for addition, it's 0 property. So if you multiply a number with 1, it should also give you that number. So identity property is basically, if it's addition, if I add a number to 0, it should give me that number. If I multiply a number, it should give me also that number. Inverse property is the number. If you have a number, there's an inverse, and that is its negative. So we have here 5, and its inverse should equal to 0. Negative 4, and its inverse should equal to 0. This is for addition. For multiplication, it's going to be the reciprocal. The reciprocal is that number and raise it to negative 1. And this is just 1 over a. So the multiplicative inverse of a number is 1 over that number. We have here 5. The multiplicative inverse is 1 over 5, and that gives us the identity 1. Commutative property. In this, when you have a sum, let's say 5 plus 7, it is the same as saying 7 plus 5. 5 plus 7 is 12. 7 plus 5 is 12. So order does not matter. This is for addition. How about multiplication? Same thing. If we have 5 times 7 and 7 times 5, it would result in the same thing. Order does not matter. How about the commutative property of subtraction and division? Well, you can just say when you're subtracting, it is just adding a negative number. So 5 minus 7 is the same as saying 5 plus negative 7. And since we're in addition, you can just use the commutative property of addition. Same thing with multiplication. What's the difference between 35 divided by 5? Then just saying 35 times the multiplicative inverse of 5. Since we're in multiplication, you can just use the commutative property of that. Associative property. Same thing, we have for addition and multiplication. And associative property and associative property are for 3 or more numbers. So when you have 3 or 4 numbers, the way you group them is the same. We have here 2 plus 3 plus 4. 2 and 3 are grouped. On the other side, we have 3 and 4 that is grouped. Using order of operations, we have 5 plus 4 on the left-hand side, 2 plus 7 on the right-hand side, and their sum are the same. Same thing for multiplication. 2 times 3 times 4. Same thing for multiplication. Here we have 2 and 3 are grouped. On the right-hand side, we have 3 and 4 that is grouped. 6 times 4 and 2 times 12 will give you the same product. Lastly, we have distributive property. And it says, if you have a number and it's multiplying the sum of two numbers, it's the same as saying a times the first number plus a times the second number. So you've distributed a to both b and c. We have an example here. We have 3 times the quantity 1 plus 4, and we have 3 times 1 and 3 times 4. If we use order of operations, inside the parentheses first, we would have 3 times 5. Over here, we have 3 times 1 is 3, 3 times 4 is 12, and you would get the same product. Let's have one more example before we go on to the activity. Let's say I have 5 and I'm going to multiply it to 2 minus 3. That is the same as saying 5 times 2 plus 5 times negative 3. Because remember, when you're subtracting, it's the same as saying you're just adding the negative number. 2 minus 3 is the same as saying 2 plus negative 3. Using order of operations, 5 times 2 minus 3 is negative 1. Is it the same as saying 5 times 10? Is it the same as saying 5 times 2 plus 5 times negative 3? So this would be negative 15. 5 times negative 1 would give us negative 5. 10 minus 15 would give us negative 5. So it gave us the same result. Let's do an activity before we finish. Complete the table. Which property justifies each statement? Number 1, we have 0 plus negative 3, and it gave us that number also. So this is just your identity property. Number 2, we have here the product and the sum of two numbers is the same as saying the product of the two numbers. This is distributive property. Number 3, negative 6 plus 7 is the same as positive 7 plus negative 6. The order does not matter, so this is commutative. Number 4, 1 times negative 9 is that number also, so this is just identity. Number 5, we have negative 4 and negative 1/4 give us the identity, so this is the inverse property. Number 6, 2 and 3 are grouped, 3 and 4 are grouped, so this is associative property. Number 7, we have 10 plus its inverse give us 0, so this is the additive inverse. Number 8, we have 2 times 5 and 5 times 2. This is just commutative property. Number 9, we have the product and the sum of two numbers is the same as the sum of the two products. So this is distributive. Number 10, if 9 and negative 10 are integers, then their sum is also an integer. And this is just closure property. That's it. End.